Okay, let's dive into the forecast signals for winter 2026. We've got some sources pointing towards a pretty significant risk for severe cold, maybe high volatility too, across North America.
That's right. And it seems to be driven by a really powerful oceanic event, something quite unusual.
Yeah, this Northeast Pacific 2025A, or NEP 25A, it's described as having exceptional magnitude, especially this early. So our mission today is figuring out how this ocean heat wave connects with everything else to, kind of surprisingly, set us up for major cold.
Exactly. And NEP 25A, it's what we call a marine heat wave in MHW. Basically, sea surface temperatures much warmer than normal for a long stretch.
And it's right after NEP 24A, wasn't it?
It is. We're seeing these big events happen more often, which is notable.
Hold on, though. If the Pacific is so warm, wouldn't that usually mean, a warmer winter, at least for the West Coast? Why are we talking about cold risks?
That's the key twist. It comes down to something called the atmospheric bridge. All that extra ocean heat, it doesn't just sit there. It pumps heat, huge amounts of it, into the air right above it.
Okay.
And that warm air column expands, it stabilizes, and essentially builds this persistent, strong dome of high pressure right over the Northeast Pacific.
Like a heat dome, but over the ocean.
Sort of, yeah. And this massive high acts like an anchor. It basically forces the atmosphere into a specific pattern, a dominant positive phase of the Pacific North American pattern, the PNA.
Right, the PNA, that controls the flow, doesn't it?
It really does. Think of it like setting up the lanes on a highway for weather systems. A positive PNA, locked in by that ocean high, forces the jet stream way up north over the west coast, and then it has to dive sharply south downstream.
Downstream meaning east of the ridge.
Exactly, east of that big high. So the ocean warmth actually sets up the pathway for cold air delivery later on.
Wow, okay, so the ocean forces the jet stream shape. But you mentioned it's not just NEP 25A, there's this triple threat idea reinforcing the cold risk. We have the NEP 25A ridge. What else?
Okay, so number 2 is the tropical background. We have La Niña likely developing. NOAA issued a La Niña Watch. Last I checked, it was a 71% chance for October-December 2025.
La Niña. Okay, that often means colder winters for parts of North America anyway.
It does, and when you combine it with the NEP 25A ridge, you get this dual forcing scenario. The ridge acts like a huge wall, and La Niña adds momentum to the flow across the Pacific. That combination really exaggerates the southward plunge of the jet stream east of that ridge.
So a deeper dive of cold air.
A much deeper dive. You get strong meridional flow. That means air moving north to south, pulling Arctic air deep into the central and eastern U.S. and Canada.
Got it. And the third driver, something about the stratosphere.
Yeah, the stratospheric influence. Early long-range signals point towards a potential weakening of the polar vortex this winter.
Okay, and a weaker polar vortex means?
It makes major atmospheric blocking events more likely. Those patterns where the weather just gets stuck for weeks. Combine that instability way up high with the dual forcing from the ocean and the tropics, well, the cold risk gets seriously amplified.
And the timing points to December 2025, January 2026 as the peak risk period.
That seems to be when these factors are lining up most strongly, yes.
So, recapping the impacts, big cold for central and eastern North America, milder out west near the ridge, and probably more snow than usual for places like the Great Lakes, maybe Iowa, Wisconsin, Illinois.
That's the general picture emerging, yeah. But here's a really critical point. We need to talk about the forecast models themselves.
Okay, what about them?
These long-range models, the S2S ones, they often have a known bias. When they react to really strong drivers like this massive marine heat wave in EP25A, they tend to simulate a response that's, well, too weak.
Too weak. What does that mean for us, practically speaking?
It means the models might be underestimating just how deep and persistent that cold air trough over the continent will be. Geopotential height, which they forecast, is like a measure of the air mass thickness. If the model response is weak, it's not fully capturing the strength of the cold setup driven by that exceptionally strong NEP 25A heat source.
Ah, I see. So the actual cold, the depth of it, could be more severe than what the average forecast map might be showing right now.
That's exactly it. Think of the current forecasts, the outlooks you see, as maybe the minimum level of cold we should expect, the lower threshold.
Right.
Given the strength of these drivers, the ocean, the tropics, the potential stratospheric connection, the actual severity could quite easily exceed what the models are statistically averaging out.
So this isn't just a typical winter forecast. It's a high leverage situation, meaning the potential for extremes is maybe higher than usual.
I think that's a fair assessment. It really calls for careful planning, utilities, agriculture, transport, And interestingly, because of that weaker polar vortex connection, the ripple effects could even reach Europe, so the monitoring needs to be pretty broad. It's definitely one to watch closely.